Hello. So let us see the example question number 3.6. That is a question from current electricity based on Kirchhoff's law. Okay. So looking into the question, this is actually example 3.6 in your textbook. Okay. That is Kirchhoff's law based problem. So here the question is a battery of 10 volt. Here you can see a battery of 10 volt of negligible internal resistance is connected across the diagonally opposite corner of a cuboidal network. So this is a cuboidal network of 12 resistors. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 resistors are there in total. Okay. Each of resistance 1 ohm. Okay. Each resistor is having a resistance of 1 ohm. Determine the equivalent resistance and you need to find the current I. Okay, so now looking into the diagram, here it is given the current coming from this 3 volt battery is 3I. Okay, and when it reaches this junction, we can apply the junction rule. So this 3I is getting splitted into 3 equal parts I. Okay, and when this I is reaching here again 2 branches, so I gets splitted into I by 2. Here also I by 2, here also I by 2. And here at this junction, 1 I by 2 and 1 I by 2 is coming and joining. So I by 2 plus I by 2 I. At this junction also, I by 2 and this I by 2 is joining I. At this junction, I by 2 and I by 2 joining I. So at C dash, I, it will be 3I coming back to the battery. So this is forming a closed loop. Okay. Now we have to find the equivalent resistance. So now when you check this cuboidal shape, we cannot simplify it further. Whether it is series or parallel, it will not be possible. So we have to apply Kirchhoff's law here. So when you apply Kirchhoff's law, when you check this A and C, this is actually the body diagonal of that cube. So just imagine this is a cube. So this is a normal diagonal. From here till here, this is a normal diagonal. Body diagonal means from this corner towards this corner, into that cube. Body diagonal means from here till this point, that is body diagonal. So over here you can see A and C dash are the opposite corners, so the diagonal will be the body diagonal. So we have to find equivalent resistance and current I, and over here the cell of 10 volt is connected across the body diagonal or across the opposite corners of this cube. Okay, now for solving this question, this very easy question, for solving this question you need to consider only one loop, that is A, B, C, C dash, E, back to A. Okay, so coming to the naming, here it is given the bottom corners of this cube is A, B, C, D, and the vertically opposite you have above A dash, above D dash, B dash, C dash. That is how the naming is given. Now here, for finding the answer, we just need to consider only one loop, that is with A and C dash, with those two corners or those two opposite corners, A, B, C dash, E, A. Now A to B, my direction, current direction same, so it will be minus IR. So applying Kirchhoff's loop rule, you will get minus IR. Then A to B it is minus IR. Then B to C again minus I by 2 into R. Minus I by 2 into R. And C to C dash it is I into R. So minus I into R. My direction, current direction same. So it will be minus I into R. Then coming back to the battery here, negative to positive. So it will be plus E. So plus E is equal to 0. Now taking all the IR terms to one side, you will get IR plus IR 2 IR plus I by 2 R. When you simplify, you will get it as 5 by 2 IR. So E value, EMF value is 10 actually. So you will get it as 5 by 2 IR. And we know R equivalent will be equal to the total potential E by the total current. So over here, the total potential E is 5 by 2 IR. So 5 by 2 IR by total current is 3I. I cancel. So you will get it as 5 by 6 R. Okay, now R value is given as 1 ohm. Okay, so R equivalent you will get it as 5 ohm. This will be the value of R equivalent. Okay, now we know V is equal to IR, the normal Ohm's law formula. V is equal to IR we know. So V is 10, I is 3I, and R equivalent is 5 by 6. So when you rearrange and simplify, you will get the value of current as 4 ampere. I is 4 ampere, so this is 4 ampere. Okay, and 3I means it will be 12 ampere, and I by 2 means it will be 2 ampere. Okay, so if they specifically ask particular branch what is the current, you can just write it according to the diagram. Over here, here, wherever you have I, it will be 4 ampere. 3I means 3 into 4, 12 ampere. I by 2 means 4 by 2, 2 ampere. Okay, so this is how to solve this example question. Okay, this question is important, as well as an example, that is example 3.7 is also important.